So this is going to be the first video in the series of videos that we need to put out weekly. Okay, so I want to start off by showing the game that we are modeling our OOP game after. So this game is called Hotline Miami 2, and it's a top-down shooter, and it has a couple of unique features that we really wanted to replicate in our game. So as you can see that there's a camera that follows the player around, so that's something interesting. And then we have this terrain, and we have doors, walls, enemies that different types of enemies. You have weapons available on the map that you can find and use. So yeah, that's the idea. So now I want to go to my GitHub repository, and then I want to go through our UML. So our GitHub repository is currently in my own repository and not the Habib one. So everything that we've created so far is on the repository and it's public. So this is our UML. So the UML is being updated as we go along because of the different things and needs that arise throughout the process of development. So I'm going to quickly go over the entire UML. So we have three major classes: the camera, render, and game class. So the game class handles all game processes. The rendering class basically will be this class that is responsible for rendering everything in the game. So every object basically. And then we have the terrain. So the terrain is gonna have different types of things you can find in the map, in the level. So we'll have windows. So the window is something that we've created ourselves. So the window is going to be an object that you can attack and deal damage to, and eventually create yourself a new pathway. You'll have doors that you can go through, and then you have walls that are obviously unpassable. Then we have the people's class, and the people's class is basically creating two other child classes. So we'll have this player class. The player class will be responsible for the player, and it'll have all the similar characteristics that the people class has, and then some more obviously. Then obviously we'll have the enemy class. There are different kinds of enemies. So as you can see, we have a boss enemy being derived from the enemy. So this boss enemy will have special attributes that the enemy class might not have. And then I want to come to the weapons class. The weapons class is gonna be a parent class, and then in that class we'll have two types of weapons. You'll have a firing weapon and you'll have a melee weapon. So as you can see, we have a baseball bat, we have a minigun, and a gun. So they still share much more or less very similar attributes. So we've put them together in the same class. Now I'll quickly go to our code, and while I go through the code, I'm gonna be talking about who's done what so far. So we have 4 people in our group, and Maaz has been so far very much responsible with the UML process creation, and he is working on the loading screen and the game over screen that you can see in our UML right here. So these are two classes. Similarly, Affan has been making the game class that has different functionalities such as like the people class and their functions and stuff like that. Sabah has been working on the SDL. So as you can see in the game class, we have a lot of SDL work done that's rendering different types of things. So we have the sprites, the enemies, and we have the background, stuff like that. So that's what Sabah's been up to. And I've been working mainly on debugging the code, creating the weapon class, and creating this event handler, things like those. So I'm in charge of that, and I've been also managing the project. So I'm gonna now be showing you a quick look of what the game actually looks like in its current phase. So we've gotten a bit ahead of, I wouldn't say ahead, but considering the game is tough, so we are quite ahead in the game development cycle. So we already have objects rendering on the screen, and we have a background image. Obviously we haven't coded the collision, so you can just walk on water and go outside the map. That is going to fix itself eventually. As you can see, we've already coded the enemy to be able to follow the player wherever the player goes, even if it means a diagonal following, and the enemy is basically taking the quickest path to the player. This needs to be tweaked a bit, and that's what's going to happen. So the idea is that the player needs to go near the enemy, and then the enemy will follow the player. So that's the idea. So yeah, so that's what the game looks like right now, and we're working on it. And thank you for watching.